Hello, everyone. So, to discuss with you the Bridge Lab experiment, as you can see, I've sent out an announcement letting you all know that the Bridge Lab experiment has opened. So, where do you find it? A lot of you like to email me about where to locate things. Typically, I'll send out a link. If it isn't a link, or if there isn't a link attached to the announcement, that means this assignment is likely in Pearson. Now, I know I showed you all this at the beginning of class, but many of you are still emailing me where to find homework, quizzes, and exams. So let's go take a look. Exams are in course materials. Once you select course materials, you should be able to launch your courseware. All right, so after you launch your courseware, you'll open My Lab in Mastering. And when you get to My Lab in Mastering, you will see your assignments. And all of these assignments will pop up for you, like chapter 6, homework 6. Chapter 6 homework, it's due today by the end of the day. Quiz 3, past due. Quiz 2, past due. Chapter 5 homework, also past due. But as I mentioned before, homeworks are acceptable if they are late. So you're good on that. Now, your exam, test 1, chapters 1 through 6. That exam will open on February 16th at 8 a.m. in the morning. It will be due on February 19th by 11:59 p.m. This is where the exam is located. All righty, glad that you see that, and I'm signing out of that. Now, back to Blackboard. Hmm. Sorry, Blackboard. Now, the lab experiment, it is in course content, and then if you go to the labs folder, you'll see the Bridge Lab. You'll see the assignment for the Bridge Lab report, and you'll see the assignment for a Bridge Lab notebook. Let's look over the Bridge Lab first. Bridge Lab content, what needs to be accomplished here. First, you're going to build a bridge. Now you see this lovely picture here. You're going to build a bridge. Now, how are you going to build this bridge? There are things you need to know. There are certain materials that are required for building this bridge. Now, you may not have toothpicks. You may not have even popsicle sticks, but you should have paper, right? So you can build this out of paper, and it's going to be made up of basically you're going to have your structure for. Let me find the material. This one sheet. I can. All right, here we go. So background, I'm gonna go over that. You can read that on your own, but where I want to go over design criteria. If you select toothpicks, but notice, like I said, you may not have toothpicks, but you may have paper. So you'll use your paper plus some tape or glue to build such a structure that you could span over maybe two books. Uh, you know, something that will allow you to elevate your bridge and allow it to span across the two objects. Spanning is basically just obviously spanning should be self-explanatory, but you're going to place it over the two objects that are separated a certain distance apart. All right. And then after you do that, you'll place weights on the framework of your bridge to see how much weight your bridge will hold. All right. Now, what you're going to need to do, you come down here. You're going to have to calculate the cost of your bridge with each member costing $1,000 for the members, and your members would be your toothpicks or your sheets of paper that would allow you to create the trust framework. All right. Now your nodes, each node costing $3,000. Each node is with contact points. So if your paper contacts another sheet of paper, or your toothpick contacts another slide. This is this long bar here. If you made that up of multiple toothpicks, wherever you're gluing the toothpicks together would be a node. So you have 5 centimeter tape, glue, So another toothpick that's 5 centimeters. This particular point here would be a node. So for each node, your cost would be 3,000. For each member, 1, 2, 3, 4, 5, 6, 7, 8. That's 8. 1, 2, 3, 4, 5, 6, 7, 8. 8. All right. That's just if you build your trust like that. So that would be 16 total members. So that would be costing you $1,000 per member. 16 total members times 1,000 is $16,000 plus the number of nodes. So 1, 2, 3, 4, 6, 8. That's 8. Then you multiply that times 3,000, which is 24,000 plus 16,000. That will total you $40,000. All right. Now, with that being said, this is two-dimensional. So it's going to have to be three-dimensional. All right. So you would have to double that. And that would be $80,000. And then what you would do, you would calculate how much your $80,000 bridge held. Right. And then you would determine if the money you spent, not actually, but from experimental cost analysis standpoint, how much money would your bridge cost you? And then how much weight would you be able to hold based on that cost, right? So how much weight does your bridge hold based on the cost, or how much it would analytically cost you to build it, all right? And then you would report that in your conclusion, whether or not you think that is good or not. Now, as far as your experiment goes, once you perform your experiment and complete your experiment, all right, you're going to have to write a report on your experiment. But before we jump into the reporting of your experiment, let's go into the lab notebook portion of your experiment. And there is a example for your lab notebook. You can find it in templates. So you have, notice, look at, you have your lab notebook sample. You also have your report template. So we go to your lab notebook sample and we look at that. All right. And so this is how your lab notebook is set up. All right. So we'll start out Bridge Lab. Need problem definitions. So what do we need to do? We need to design, build, and test this bridge. All right. The span must be 8 times the longest building material. All right. So whatever my longest building material is, which it should be 5 centimeters, and then you multiply the span, it must be 8 times that. So I'll multiply 5 centimeters times 8 centimeters gives me 40 total centimeters. That should be the length, total length of my bridge. All right. So the material, do you write down your B material can be anything that is available. All right. But you don't say the material can be anything available. You say A, the length of my bridge is this. B, the material I used is this. You don't have to create 4 designs. You only need 1. So this right here, you have create 4 designs. No, create 1 design. Run your simulation, meaning test the weight of your bridge, right? For D. E, calculate the cost of your bridge that you just made or designed and then built. And then F, build and test it. So you're jotting down all of these things that you're going to have to accomplish and your things that you're going to define. All right, researching how to build a bridge that will hold the most weight. That's just doing a quick research, going to Google. What's the best type of bridge structures? That's the research you're doing. And then citing your sources. Obviously, trusses are a strong structure, right? For bridges. Then after that, you're going to come down here and you're going to draw out, conceptualize, design one. I want to look like this. Like I said, you only need 1 design. But if you want to brainstorm between multiple, sure. Draw out some quick sketches of some concepts you may need, or patterns, truss patterns you may want to use. And this is where you would draw those. This is where you would sketch those. And then this is also where you can do your cost analysis, right? You can do that here, right here in this lab notebook. Also, procedural steps. What steps you took to, or steps you, the steps you took to build your bridge. Write it here. Jot that down in here. All right. Now you don't have to run the simulation, so don't worry about the simulation. It normally doesn't even work anyway, so please disregard the simulation. All right, so that's the lab notebook. Then let's go back to course content. Course content again. Templates. And then you have your report template. Now remember, that was your lab notebook. This is the reporting of your experiment. And this is how it goes. So you can work in a group. You don't have to work in a group. You can work in a group. You do work in a group. Just list the name of your group members here. Also, if you do work in a group, every member needs to turn in a report. Now, if you're working in a group, the report writing should be the same for each group member, but each member still needs to turn in the report. All right, so first thing is your abstract. Your abstract really simply lists what you are trying to accomplish and whether or not you accomplished it. That's your abstract. We set out to accomplish this objective, and the objective was accomplished by doing this. That's your abstract. The objective is what are you trying to accomplish? You're listed there. Theory and analysis. What types of calculations do you need to do to resolve this experiment? That's what goes here. Materials, you'll list your materials here. The procedure. What design steps did you take for developing this experiment, running this experiment, proving this experiment? All right. Result section should be self-explanatory. You list your results here. This design bridge was tested. It held so many weights. And you have a table here. It's conceptual. Weight held, cost of bridge. You only have one concept, so it only needs to be one. Be the weight held, cost. Done. All right. Then discussion. Anything that you could think of is in regards to issues you needed to overcome, things that would go there, right? This section allows you to explain what the results mean, to point out their significance. So from your cost to your weight, just discuss that there. You know, and then also, how did you overcome certain issues you may have had? Or if there were no issues, then you were good to go, right? But you would how discuss that in your discussion. Then your conclusion should merely state that you overcame or you accomplished what you set out, what your objective was. You accomplished that objective. And you would also make any recommendations based on the findings, right? So if you found out that, hey, we could have saved costs here by doing the design this way, or we could have held more weight by doing the design this way, you would also state that also in your conclusion. Now, your appendix should have pictures of your lab experiment. You showing the final concept built, you showing the pictures of your bridge spanning over the two objects that you placed them on, you showing the bridge with weights, you showing the bridge breaking or not breaking. All right, that's it. Those pictures need to be captured, placed in your appendix, and then you'll need to cite your sources, right? Wherever you did any type of research, just list those sources here. And that is it. Make sure you check for grammar, spelling, commas need to be commas need to be placed correctly. You need to write your lab report in past tense because once I see this, it will be something done in the past. So that's how you need to write it, as if it was in the past. Even when you're writing this report, it would have been in the past anyway. All right, so that's the lab experiment. Any questions, please feel free to email me. And I think that's it. All righty. Hope you enjoy doing this experiment.